All right, let's do SO3. So again, the first thing you should do is just write down what elements you have from the formula. There's 1 from the sulfur, there's 3 from the oxygens. Now we got to figure out valence electrons. Here's sulfur, here's oxygen. They're both in group 16. That means they have 6 valence electrons each. So sulfur has 6, 1 times 6 is 6. Oxygen also has 6, 3 times 6 is 18. So 6 and 18, add them up, and you get 24. So there's 24 electrons that these guys are all going to use. Now, what goes in the center? Well, we can look at our little guide here. If we look at the guide, it says start with carbon or silicon. We don't have silicon, we have sulfur. We don't have nitrogen or phosphorus, but we do have this green column, oxygens and sulfurs. So now you kind of got to look at your, numbers and see what you have. We only have 1 S and 3 O's. So again, symmetry is nice. Go with the S in the middle and put the O's on either side of it. And then the other O, you can put top or bottom, doesn't matter. I'll put it on the bottom here. So I just picked my center atom and I connected all the outer guys with single bonds. Now I'm at step 4. Step 4 says give all the outer guys an octet. So oxygens all around the sulfur, they need their octet. They need to have 8. Right now they only have 2 in the bond. So I'm going to give it 6 more. So that guy has an octet. I'm going to give this one 6 more. Plus the 2 it shares, it has an octet. This one gets 6 more. So all my outer guys have an octet at this point. I just finished step 4. Now I have to make a decision based on how many electrons remain. You have to know how many electrons remain. We had 24. We now use 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 24 minus 24 leaves us with nothing. We had 0 remaining. That doesn't mean you're done. It just means you have no more electrons to divvy up. Now start going through your list here. I was done since the center atom had an octet. Is that true? Let's look at your center atom. Does it have an octet? The answer is no. It has 2, 4, 6, not 8. And there's no more electrons there to put on it. We had to know that there's 0 left, because if there was 2, we would have put 2 there. But we're not done. The center atom doesn't have an octet. Then we go to our next choice. I put the remaining electrons. What remaining electrons? You don't have any. So you can't do this and you can't do that. So now we go to a third option. I had to make a double or a triple bond. So here's what you do. That sulfur in the middle, you're going to look at one of these oxygens. It doesn't matter which one. Eeny, meeny, miny, moe, pick your favorite one. I'll pick this one down here. And this sulfur is going to look at that oxygen and say, hey, you got 6 that you're not sharing with me. You're only sharing 2. Is there any chance you could share more than 2? So little oxygen says, sure, I'll share eeny, meeny, miny, moe, this set. It doesn't really matter which set you pick. But this set is no longer going to be just around this oxygen. Instead, it's going to be a double bond. So I'm going to actually erase this set right there. So now I have 6 around this guy in a single bond, 6 around this one in a single bond, but only 4 in a double bond. I wouldn't have known to do that if I didn't realize that I had none left and that center atom wasn't happy. So that's how we know to convert unshared electrons into double or sometimes triple bonds. Let's do another one here. We got carbon and oxygen. Carbon, there's only 1. Oxygen, there's 2. Carbon is in group 14. So there's 4 valence electrons. Oxygen has 6 valence electrons. 1 times 4, 4. 2 times 6, 12. 4 plus 12, 16. So we got 16 electrons. Your center atom is going to be carbon. Connect the outer guys with single bonds. Now, the next rule, we just connected them with single bonds. Next rule is use the remaining electrons to give the outer atoms an octet. So let's go give our outer guys an octet. This oxygen will start here. Let's give it 8. So we're going to put 6 more on it, so it has a grand total 8. 2, 4, 6 plus the 2 in the bond is 8. This guy gets the same thing. 2, 4, 6 plus the ones in the bond, 8. I gave my outer guys an octet. You're not done though, because now you have to make a decision based on how many electrons remain. You have to know how many electrons remain. So it means add them up. 2, 4, 6, 8, 10, 12, 14, 16. We've got 16 already in our picture, and we started with 16. 16 minus 16 is 0. I have none left. So let's go through our checklist. The first thing says, I was done since the center atom had an octet. No, you're not done. The center C does not have an octet. It has 2, 4. It doesn't have 8. So that's false. The next line says, I put the remaining electrons on the center atom. We don't have remaining electrons. You don't have electrons to put on the center atom. And this is what happens when kids don't pay attention to how many electrons they have left. They look at that center atom and they say, hey, that's not right. It needs to have 4 more. So they make up 4 electrons out of thin air. Electrons that don't exist, and they just draw dots on there. You can't do that. You have to realize 0 remain. So you can't do that either. That's how you know I've got to make a double or a triple bond. That's how you know you've got to rearrange some of these electrons. So this carbon, eeny, meeny, miny, mo, looks at one of them and says, hey, can you share some electrons with me? So this oxygen says, sure, I'll share, I don't know, maybe this pair up here. And I'll turn it into a double bond. So now we have 4 going back and forth. These guys technically don't exist. They got turned into a bond. Over here, the same thing happens. Get rid of that set. Turn it into a double bond. So then I'll erase them so we don't get confused. So now, if we look at our drawing, we still have 2, 4, 6, 8, 10, 12, 14, 16. We still have 16. They're just rearranged a little differently. This is what it looks like, a double bond on either side. Now, could there have been a triple bond on one side and a double bond on the other? Or a single bond on the other, rather, with electrons like this? Yes, as long as everybody has an octet, it can shuffle back and forth between a triple bond on this side, 2 on each side, or a triple bond on this side. Nature likes symmetry, so if you have the option to make something symmetrical, go for it. All right, let me show you how to handle 2 elements, because you don't really have a center atom. So we got nitrogen. There's 2 of them, and if you look on the periodic table, nitrogen is here in group 15, so it's going to have 5 valence. So 2 times 5 is 10. There's 10 total. Now, N and N. What are you going to put in the center? N. That's all you got. Now, here's the way you should be thinking about this. From here on out, you are going to pretend that one of your 2 is really the center. I know it doesn't make sense because it's really just the left and the right, but we're going to pretend that this, I'm going to give this a little star. This is my captain. This is my center, N. The other one is an outside, N, because that's going to become important when we follow the rules. So we figured out how many total electrons. We picked our center atom. This guy is the captain. This guy gets our little star. This is our center N. We connected the other one with a single bond. So far we've still done step 1, 2, and 3. Now we're going to use the remaining electrons to give all the outer atoms an octet. So remember we said, this is my center, this is my outer. I'm going to give this guy an octet. 1, 2, 3, 4, 5, 6. Plus the 2 in the bond is 8. That's my outer one. Give it the octet. Now we continue on just like normal. Make a decision based on how many electrons remain. So let's go back. How many electrons remain? There's 2 in the bond plus 2, 2, 2. So we've used 8. We had 10. 10 minus 8 gives us 2 left. So what do we do when there's 2 left? Let's use this box up here. I'm going to erase this stuff. If there's 2 left, go through. I was done since the center atom had an octet. No, this is my center atom. It doesn't have an octet. In fact, it only has 2 electrons. Nowhere close to 8. So we're technically not done. I put the remaining electrons on the center atom. All right, let's do that. Let's put the 2 remaining electrons on the center atom. But are we done? No. Now it has 1, 2, 3, 4. Still not 8. So now we got to look at our last option. I had to make a double or a triple bond. So this nitrogen, our captain, our center guy, looks at the other one and says, can you stop hogging all of these electrons? Can you share some more with me? So this nitrogen says, sure, I'll take these 2 and I'll put them on a bond and I'll let them zip back and forth between the 2 of us. So those 2 at the top aren't unshared anymore. Now they're shared. And this nitrogen over here says, that's good. Now I have 6 electrons. 1, 2, 3, 4, 5, 6. But you still have 8. Can you help me out still? Can you maybe send these guys over? Turn them into another bond. So I'm going to erase them because they don't really exist anymore just around the nitrogen. Instead, they're zipping back and forth between the 2. So now this nitrogen, the center one, has 8. 1, 2, 3, 4, 5, 6, 7, 8. And so does this one. 1, 2 are on the outside. 3, 4, 5, 6, 7, 8. Everybody's happy because everybody has 8. These electrons zip around this nitrogen and they zip around this nitrogen. Everybody's got the 8. All right, let's look at O3. We got oxygen. There's 3 of them. Periodic table says oxygen has 6 valence electrons. 3 times 6 is 18. So we've got oxygen, oxygen, oxygen. The rule is give the outer guys an octet. So it's got 2 already. Put another 6 there. Now it's got 8. This one, it's got 2 already. Give it another 6. Now it's got 8. So let's look at our total. We've got 2, 4, 6, 8, 10, 12, 14, 16. 18 minus 16 leaves us with 2. We have 2 electrons remaining. So let's go through our checklist. This should start to get in your head. You shouldn't have to write this down all the time, but you should start thinking of this in your head. Are you done? Does your center atom have an octet? And the answer is no. It has 1, 2, 3, 4. That's it. So we're not done. Then it says I put the remaining electrons on the center atom. Well, I have 2 remaining ones, so let's put them on the center atom. But are we done? Does my center atom have an octet? And the answer is no. It has 2 plus 2 plus 2, 2, 4, 6, but not 8. So we have to keep going. You can do more than one. You can put the remaining electrons, realize you still don't have enough, and then you could do this step. Make a double or triple bond. So in this case, the center oxygen is going to look eeny, meeny, miny, mo, one of the sides, doesn't matter, and say, can you share with me? And that oxygen says, sure, let's make a double bond there. And we'll get rid of these 2, because now they're going to be in a bond, zipping back and forth. not just hanging around outside of this oxygen. And now if we look at everybody, 2, 4, 6, 8, 10, 12, 14, 16, 18. All 18 are used. Everybody has an octet, and we're happy. The last thing we have to do is just talk about how to do this for ions. What do we do with those little charges? And then we're done. All the rest of the images that you're going to come across, you do the exact same way. Go through these steps, step by step. You'll always have your notes here. Go through them. But the biggest thing that you need to do is make a decision based on how many electrons remain. That is going to be the key determining factor in whether you get these right or wrong. You've got to know, after you give the outer guys an octet, how many electrons remain. And then just go through this little checklist. And then you should be able to wrap up your molecules perfectly. So let's go see how we do the last two.